Good morning, all. Am I audible?
Yes, you are audible. Am I audible, sir?
Yes, madam. Yeah, you are audible.
Is his voice is clear?
Yeah, well, the voice is clear. Yeah,
Okay, thank you.
yeah, thank you. Jagdish, is my voice clear? Yeah, very good morning. Yeah, may I know the participants? Yeah. Yeah, Vishnu. Vishnu, you can be on mute. So, good morning to one and all present here. Sir, with your permission, can we start?
Please start.
Yeah, okay, thank you.
Good morning and a very warm welcome. On behalf of the Department of Civil Engineering, NIT Andhra Pradesh, I welcome you all today for the inaugural function of the 5-day virtual GIAN course on nanomaterials for water treatment. This is the first program of its kind to be organized by the Department of Civil Engineering and the second program at the institute level. Global Initiative of Academic Networks in Higher Education is aimed to tap the talent pool of international scientists to encourage their interaction with the institutes of higher education in India. This is an effort to augment the country's existing academic resources, accelerate the pace of quality reform, and elevate India's scientific and technological capacity to global excellence. These 5-day online GIAN course on nanomaterials for water treatment helps to garner the best international experience into our system of education, enable interaction with the best academic experts, and also share their experience and expertise to motivate people working on relevant areas in our country. Now I welcome Dr. Vinoth Kumar Raja, GIAN Coordinator, NIT Andhra Pradesh, to brief about GIAN initiative.
Thank you very much, Dr. Reshma. Respected Director, Professor CSP Rao, and respected Professor Horace Mamne Sendel, Head Environmental Engineering Program, Tel Aviv University, Israel, and respected heads of the departments, deans, and faculty members, and dear participants, I wish you all a very good morning. Today I would like to brief about the GIAN program, especially the courses being organized by our institute, NIT Andhra Pradesh. This GIAN program proposed to gather the international experiences into our Indian education system and enable interactions of students and faculty members with international experts and academicians from all over the world and share their experience and expertise, and also to motivate the people to work on Indian problems. So with that motivation, the GIAN program was proposed, and there were several calls also made by the GIAN office located at IIT Kharagpur. The first and second call, we were not able to participate since we are the new institutions, new institution. And the third call, we could able to participate with the kind supportive and advices given by our beloved director. If you look at the statistics of education system in India, as per our Ministry of Education data 2020, India has over thousands of universities, and which include central universities, state universities, deemed universities, private universities, and national importance institutions like IITs, NITs, AIMS, ISRs, and IIITs, and many other institutions. In addition to that, we have more than 52,000 of colleges like government degree colleges, private degree colleges, self-supported degree colleges, postgraduate research institutions, and these all are functioning under the university. But only 200 institutions from the country is eligible to participate in the GIAN program, those having NAC and NIRF ranking, which determines the quality of education of the institution, infrastructure of the institution, research of the institutions, and teaching and learning and placement, etc. And as I said, we were able to participate in the third call of GIAN program, And our director was advised to make a proposal from our institution by mentioning that the potential of the institution and potential of the faculty members who all are working in our institution. And several evaluations made by GIAN office located at IIT Kharagpur. And finally, they were admitted as to one of the participating institutions for this GIAN program. And at the third call made by the GIAN, and we submitted 9 proposals in the third call. And so far we have got accepted for 7 proposals. So we are very much happy to say that almost 80% of accepted rates we could able to make it by submitting the proposals for the GIAN courses. Here I would like to point out that the GIAN office is very much limiting to approve the courses. Surely this course, like nanomaterials for wastewater treatment, has the potential, so that the GIAN office accepted this proposal and granted the funding. So the experts, Professor Hades, Mamni, and internal coordinator, Dr. Baranidharan, going to deliver the lectures. I hope that the valuable lectures will be highly useful for the participants. There are a good number of participants that are registered for this particular course. And I wish you all the best to the internal coordinator, Dr. Baranidharan, for successful conduction of this GIAN program. And also convey that the GIAN cell at institute will extend the support for successful conduction of the program. With that, I would like to conclude my speech. Thank you very much.
Thank you, sir. On this occasion, it is my immense pleasure to welcome the Registrar in Charge, Dr. Jayaram, to present an overview about the Institute.
Thank you, Dr. Reshma. Good morning to all, to Honorable Director, Professor CSP Rao, to the program, to the head of the department, and to the coordinator of the GIAN programs, and all the faculty and the participants. So it's a great pleasure to tell about the institute. So NIT Andhra Pradesh is the 31st NIT established in the chain of NITs in 2015. So since the inception of the institute, the institute has initiated the UG 8 UG programs, and subsequently the PG programs and PhD programs have also been initiated in all the departments. So the institute has also been presently running from its permanent campus, and construction activity has also been completed, even though the institute is the one of the youngest institute out of all the NITs. So the phase 2 construction activities also going to be initiated soon. As well as the department concerned, many laboratories has been established for the purpose of UG and PG programs, and PG establishment of the laboratories for the research programs is also being under progress. So till date, there is 47 regular faculty along with 185 ad hoc faculty, and the teaching staff is full-fledged recruited in the institute. Similarly, we have till now almost 86 faculty development programs has been conducted in the institute, out of which 14 GIAN programs has been conducted till date. The institute is also having a good record of R&D projects, out of which one of the major projects that has been sanctioned is under CRT-DEH on the renewable energy system, to establish a center of renewable energy system in the institute, out of which 5 crores grant has been provided by the ministry, and matching grants of 2 crores is being provided by the institute. So under the leadership of Honorable Director, the institute is being growing in academics as well as in the infrastructure and in the research also, and this continues forever. As well, this present GIAN program which is being conducted is also one of the GIAN program which is conducted in this year, and I hope this program will be a great success, and the participants also will be gaining good knowledge. Thank you. Thank you.
Thank you, sir. Now I welcome Dr. Baranidharan Sundaram, Course Coordinator and Head, Department of Civil Engineering, NIT Andhra Pradesh, to give a brief introduction about the course and foreign expert.
Yeah, thank you, Dr. Reshma, Dr. Jayaram, the registrar in charge, as well as Dr. Vinoth for briefing about the coordinator of the GIAN program at the institute level, for briefing about the GIAN initiative as well as about the institute. So a very good morning to one and all present here. As the head, the Department of Civil Engineering, and as the course coordinator for this GIAN program on nanomaterials for water treatment, I warmly welcome our beloved director, Professor CSP Rao, and the foreign expert, Professor Hadas, and then Dr. Ram Sundaram. Also, I welcome all the faculty colleagues from NEGH Andhra Pradesh, the participants, and then the scholars for this event. Let me share an overview about this course. The course would mainly focus on the various synthesis routes of nanomaterials, properties, and their characterization techniques in detail. Further, nanomaterials interaction in water and their transport mechanism, both in water and wastewater, will also be discussed. Whereas their application in different domains, such as water treatment, wastewater treatment, and then advanced industrial wastewater treatment will also be highlighted in this course and then discussed in detail with live examples, where Professor Hadas has a very vast experience. The prime objective of this course is mainly to understand how the nanomaterials behave in different aquatic environments, such as water, wastewater, because wastewater is a heterogeneous matrix, and then it is very difficult to understand how does these tiny particles behave in wastewater systems. And then their application of these nanomaterials in water treatment and its advantages over the conventional treatment methods. So again, that is one more effort that has been done across the world to go for new innovative treatment methods in order to have a very good water quality. Nanomaterials with the help of advanced oxidation process, how these nanomaterials can help in treating the water as well as wastewater, and industrial wastewaters are also a matter of concern. So last but not the least, what is the risk of having this nanomaterials in water will also be highlighted in this course, which is also one such important thing to know about. So now I take this opportunity to introduce our foreign expert to the audience. Professor Hadas is the head of Environmental Engineering Program and Water Energy Lab at the School of Mechanical Engineering at Tel Aviv University, Israel. She has received her PhD from Duke University. Her research focuses on disinfection and oxidation of contaminated water, wastewater, and waste by integrating UV light-emitting diodes, technologies such as ozone, photocatalysis, reactive species, and nanomaterials. She is mainly focused on developing sustainable point-of-use technologies for safe drinking water in low-income communities, hybrid methodology for assessment of water quality, and treatment of sewage prawns without any external energy. Professor Hadas was appointed as a visiting faculty at Indian Institute of Technology, Madras in India. So thank you, Professor Hadas, first of all, for accepting our request to deliver the lecture for this GIAN course, and we look forward to hear your lectures in the forthcoming days. Now I call upon Professor Hadas to say a few words about this course and its outcome. Yeah, over to Hadas.
Thank you very much, Dr. Vardhan, and I would like also to thank the director and all the participants in this course, the students and the faculty. We all know about the importance of water and that water is actually our life. And however, water is not only quantity, but it's also the quality of the water. And nanomaterials and nanoparticles have a potential in providing us safe and pure water. It can help us in various applications, could be integrated in membranes. Nanomaterials can actually be a catalyst to enhance processes that can degrade, for example, drugs in water and pharmaceuticals and personal care products. Nanomaterials can be a source of treatment for the water, but they can also be toxic in the water. And therefore, nanomaterials can be used, need to be used smartly in the water and also to purify our water. So I'm very excited to be here. In this course, we will also emphasize application of the nanomaterials as said before, to control biofouling, as a source to treat and purify the water, and also in a way to be integrated into membranes. I'm very excited to be here. Thank you for introducing me, and I hope we'll have a wonderful week, and I hope to come to visit India very soon. Thank you.
Thank you, Professor Hajaz. I now welcome our Honorable Director, Professor CSP Rao, the Chief Patron of the course, to deliver the Presidential Address.
Sir, for your kind information, you're on mute.
Okay, thank you. Thank you, Reshma. Thank you all for all the participants of this program and the faculty of civil engineering and other people. Thank you for inviting me to be the chief guest for this function. At the outset, my hearty welcome and my greetings to all of you on behalf of NIT Andhra Pradesh. I welcome Dr. Baranidharan, Head, Civil Engineering Department. Dr. Vinoth Kumar Raja, the coordinator of GIAN programs of Institute. Dr. Jayaram, in charge registrar of the Institute. Professor Hadas Maman and Professor Ram Sundaram, foreign experts for this GIAN program. All the faculty, all the participants, all the MTech and MPhD students who are all online to go through these proceedings of this wonderful program. I think this is the second GIAN program that is going on now. Previously, computer science have conducted one program on bitcoins. This is on nanomaterials applications in drinking water or water treatment. And I am also very happy to note that for this young institution, about 7 programs were sanctioned out of the 9 programs that we applied. It's a good beginning. Let us keep on applying it, because some other institutions, about 30, 40 GIAN programs have been sanctioned. And I request all the teachers of NIT Andhra Pradesh to apply for more programs and see that their programs are approved. Coming to the very topic of this, nanomaterials for water treatment. Nanomaterials is applicable to most of the engineering problems. Materials, to enhance the strength of the materials, people are going for the mixing of nanomaterials into that. Nanomaterial applications are many in defense, are many in real-time engineering applications. The advantage could be the nanomaterial has got more surface area and to its volume compared to micro and macro materials. Maybe could be because of the reason nanomaterial has been used for a variety of engineering applications. Water being the excellent for all life, for earth, and access to quality water still remains a major challenge around the globe. I can say that only 30 to 40% of the people in the globe are getting quality water, and most others are not getting the quality of water. Quantity could be there, and in some parts of the world, quantity is also very less, very scarce water is available. They have been getting the water from water pits and other means, collecting the water in different means and using the water for all kinds of applications. So providing a quality water at low cost is a challenging problem and most wanted problem to be solved by the technocrats. Safe water supply is the backbone of an healthy economy, yet it is woefully under prioritized globally. Though India has 16% of the world population, the country possesses only 4% of the world's freshwater resources. Drinking water's safety is judged by nation standards or international guidelines, with the WHO guidelines for drinking water quality being among the most significant one and implemented by many developing countries. Reports suggest that over a billion of the estimated 6.2 billion people relying on improved water sources continue to use water that is unsafe as well. In 2015, India achieved 93% of the coverages of access to improved water supply in rural areas. However, with the shift from the Millennium Development Goals to Sustainable Development Goals, the new baseline estimates that less than 40% of the rural population is using safely managed drinking water. One of the Sustainable Development Goals of the United Nations is to achieve safe and affordable drinking water for all. And India, though its program Jal Jeevan Mission, launched in 2019, is envisioned to provide safe and drinking water through individual household tap connections by 2024 to all the households. Mission Bhagiratha is one of the very good programs started by government of Telangana, and many other governments, state governments are trying to emulate this quality Mission Bhagiratha program. They are supplying drinking water to almost, their target is to reach all the households by this year, and they have achieved almost to 90% of this, and there are only 10 to 15% is yet to be completed. And we have to appreciate the government for all for taking the proactive steps in providing drinking water, and the central government also taking the same thing and has been providing household connections by 2024 to all the citizens, all the people living in rural, tribal, and other developed areas in India. Advances in water treatment technique can play a role in achieving this goal. Particularly, among the various techniques traditionally applied for drinking water treatment, sand filtration is one of the most oldest treatment, yet best treatment. Sand filtration is initially being believed to work by size exclusion through interparticle distances. However, later studies reveals that slow sand filters develop an active biofilm around the small sand particle that are rich in bacterial population, and thereby improve the filtration power of the media. One of the challenges with the application of granular media filtration was its inability to effectively remove chemical contaminants. Besides its vulnerability to accidents and changes in flow rate. Some of the other conventionally used techniques include chemical oxidation, adsorption, chemical precipitation, coagulation, ion exchange, to name a few. The most common chemical oxidation used is chlorine, which provides an effective and robust barrier to pathogens. Chemical precipitation, on the other hand, works by the addition of counter ions to reduce the solubility of ion contaminants. This is usually followed by flocculation and sedimentation or filtration. Of the various techniques, all the techniques, Adsorption is most technically feasible and economically attractive approach for removal of arsenic, fluoride, and heavy metals from water in areas with no access to centralized water treatment approaches. For example, you take in our own campus, the groundwater the hardness of the groundwater is lies at different places from 800 to 1200, which is very, 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 dangerous. And it's not harm, it is very harmful to use continuously. Hence, we have requested the government of Andhra Pradesh, and the government of Andhra Pradesh has agreed to release Godavari waters, and we are now getting 0.15 MLD water in our campus per day for use, for drinking water as well as for general use by all the residents of the campus. Recent years have witnessed increased interest on the application of nanomaterials in the water treatment. Nanotechnology shows great promise as the best feasible way to treat persistent as well as emerging contaminants. Nanomaterials-based absorbents offer attractive alternatives to conventionally absorbents in view of their higher aspect ratio, enhanced reactivity, which in turn translate to higher absorption capacity. The smaller size of the particle also provides the possibility of constructing compact treatment systems. As I told you, the advantage of the nanoparticle is its surface area to volume ratio. Compared to microparticles, it is 1,000 times or 10,000 times more than the microparticle. So that is the biggest advantage with all the nanomaterials, hence the applications wherever wherever surface areas and volumes are matter of a subject of discussion, where the application of nanomaterials is impeccable. Recent studies have shown nanoparticles can be engineered to target multiple contaminants at the same time, thereby possible reduction, reducing the treatment cost. However, there are emerging concerns about the safe disposal of nanomaterials and their potential risk to public health and ecosystems. Yes, there are several other disadvantages. Suppose if you cannot directly handle the nanomaterials, whereas in the water treatment, many workers, they have to handle everything through hand and through some adjustments, because nanoparticles are small in size that they can enter into the body through the pores on the skin. They can easily enter into the body, main human body, and cause different damage to the human body. That's the biggest disadvantage with the application of nanomaterials. And it is a potential risk as well to public health and ecosystem. Accordingly, I am very happy that this course is maybe planned to discuss most of these aspects, how nanomaterials safely can be used for the better water treatment, and the very variety of methods of water treatment, and most economic methods of water treatment, and may also throw some light for the participants to explore to the variety of research areas, future research areas that are available in the water treatment and nanomaterials. And their interaction with the foreign experts would definitely bring fruitful, we will not only be fruitful discussion, but also may pave the way for their future directions of research and other developments. I request all the participants to, not only the participants, particularly the teachers of civil engineering department, to be continuously interact with the foreign experts and get their advices, suggestions for improving your research in this area. I welcome Professor Hadas Mamen to our institute. Madam, whenever you visit to our place to India, please do visit our institute, which is a young institute. You will definitely, and you can bless our students with all your, with all your blessings. Thank you very much. Thank you all for your patient listening to me. Thank you.
Thanks, sir, for the overview about the course.
Thank you, sir. Thanks for giving the highlights about the usage of nanoparticles in various domains, its application in water, and then what are the challenges in water treatment, and then how to deal the risk of nanomaterials when it is being used in the environment. So now I take this opportunity with the kind permission of the director to close the inaugural session and then move forward for the GIAN first lecture, that is about the introduction about nanomaterials, its synthesis routes, and as well as the characterization techniques. So with your permission, sir, we are now closing the inaugural session. I once again thank Dr. Reshma, Civil Engineering faculty, for hosting this event. And then I thank all the participants who have joined for this inaugural event. And then I ask the participants.
All the best.
Yeah, thank you, sir. Thank you. Now I ask the participants to join by 11:20 in the link that has been circulated to you all. Thank you.